Hi guys, so now we are testing the second-hand system built from Core i5-2400 and Radeon RX 470, the Sapphire Nitro model. One of the benefits of having an older generation Core i5 processor that is currently from the Thunderbird generation is that Intel was not completely locked the non-K processor there, and you can add additional 400 MHz to the clock speed. So today we are going to test how that works and the effect on the performance. Also, the Polaris-based Radeon RX 470 has relatively low clock speed, and we will also overclock it too. But for a start, let's gather some baseline results. Of course, we have already tested everything and we know how the performance is. But just for demonstration, we will run the new Cinebench R20 in multi-threaded benchmark, and we will run one game to give you the performance with the graphics card. Now we wait. As you can see, the maximum clock speed of the processor is now 3400 MHz. That is the maximum turbo speed. As you can see, just one core gets so high, and in the multi-threaded workload, when all the cores are loaded, the clock speed is 3200 MHz. So what you can expect is a 400 MHz on all these values. And some motherboards have this function called multi-core enhancements that allows you to clock all the cores at the maximum turbo frequency. And in that case, all cores will run at 3.8 GHz. If you add the 400 MHz overclock. However, our motherboard is somewhat lower end. It is ASRock Z68 Pro 4, and it doesn't have multi-core enhancements on, so you can expect multi-core speed of 3.6 GHz and max turbo speed of 3.8 GHz. So let's wait to finish the benchmark. We are not using currently the Intel box cooler, but a slightly better aftermarket cooler with a single heat pipe and incredibly high price tag of $7. And as you can see, the temperatures are quite fine. They are in the 60s, but that is not a big problem for these processors. You can verify the current speed in CPU-Z also, and the core voltage. One interesting aspect is that the max TDP is 95 watts for this processor, but the current power consumption is substantially lower. For the CPU package, that is around 53 to 54 watts. Yeah, almost 40% lower than the max TDP. The newer version of Cinebench, that is the current R20, uses AVX instructions, so it adds considerable load to the processor, and it is a relatively good stress test for catching instabilities, early instabilities after overclock. The memory clock speed is 800 MHz, that is effectively DDR3 1600.
And we're almost there.
Oh, sorry. The motherboard is ASRock Z68 Pro 3 Gen 3, and that motherboard offers two SATA 3 ports for disk devices, and it also has more USB 3 ports. So there we have our current result. It is 886 Cinebench points, and let's save it. So let's add it here for clarity. And the next thing, we'll use Far Cry 5. It is a relatively CPU dependent and also GPU dependent game. That is also with a fast test. As you can see, the GPU clock is 1236 MHz with memory at 7050. I should probably add the CPU speed in the MSI Afterburner overlay. You can see here all the values that are monitored, and you can add them in the OSD from this checkbox. So let's see, CPU clock. Here is the CPU clock. And you can see the clock speeds currently is at 3200 MHz and 1236 for the GPU. Also the power consumption of the GPU and the voltage power consumption of the processor here. We will be using the setup that we used for the tests of GeForce GTX 1650, that is a little bit below the maximum settings. which is probably more adequate for this kind of hardware. As you can see, the load on the CPU is quite high, and the game is relatively well played, or at least it is around 4 frames, so CPU speed So we have 63 average FPS with 52 minimum FPS. Generally it will be good to run the tests a few more times, but we've already done that and we get the info. That is just for illustration purposes. So 63, 52. i5, 63, 52. Okay, so now we are going in the BIOS of the, or more appropriately the UEFI, UEFI, something like that, of the motherboard. Hitting repeatedly the delete button. So I will not make a big guide on this, but here are the main things you need to change, or practically this is CPU ratio setting is the only meaningful thing. You can switch it to manual and hit the plus button until it stops. That is 38 multiplier. The multiplier is multiplying the so-called reference clock. That is in this case 100 megahertz, and that reference clock is used to get all the clock speeds in the motherboard and the processor. That is also the PCI Express clock speed, the USB clock speed, SATA clock speed, and so on. And that is the maximum turbo speed for the processor. We've applied the 400 MHz additional boost. Here you can change the power limit. Short duration power limit is basically the clock speed of the turbo, but as you can see, the processor was using substantially less than its TDP rating, that is 95 watts, so basically you don't need to change it. Here you can add additional voltage that will be needed if the processor is not completely stable with the new clock speed, and you can change the reference clock speed, but as we said, that is connected with other clock speeds, and if you change it too much, you risk your data integrity, and basically you can screw your hard drive or SSD and lose your data. Typically you should be fine if you add up to 5 megahertz, that is 5% additional overclock, but I don't think the risk of losing data is worth it, the additional several percent performance. If you want to try it, maybe you should go for 3 megahertz with 36 to 38 multiplier. That will give you additional 100 to 110 megahertz. So basically that's it. Of course, leaving it to auto, it is possible the motherboard will automatically adjust the voltage for the new clock speed. Also, you can change the voltage of the memory, the CPU, and so on. Now that's one interesting thing to mention probably. VCCSA voltage is the voltage of the so-called encore part of the processor, that is the memory controller, the PCI controller, and so on. And it is advisable that the VCC voltage and the memory, that is DRAM voltage, are not more than 0.5 volts apart, because it might lead to degradation of the processor. That's why, because we are using Kingston HyperX DDR3 1600 memory that has 1.65 volts rating for its targeted speed, that's why I have upped the voltage of the encore part. If you are using better memory that is running, for example, on 1.5 volts, it might not be needed. So save changes, exit, and we are done. 400 megahertz on the current clock speeds equals around 12% overclock, so you can expect at least 10% better performance from it, which is not something great, but keeping in mind that the processor is quite a few times running on the limits of the good gameplay performance, it might be just about enough to give you 60 frames per second. So let's see. Yep, we are a little bit better on the clock speed. So let's see what is the net result. Here you can see we are turboing above the out values, so the overclock works. Let's see what performance we will gain from this. So as you see, we are now running all-core speed at 3.6 GHz, exactly 400 MHz more. And the power consumption is around, what was it, probably 5 to 6 watts higher, but I don't think that's a big problem. As you can see, the motherboard has probably adjusted the voltage of the processor itself. If I remember correctly, it was 1.190 or something volts. Now it is 1.26, so probably 70 millivolts adjustment. You can check for yourself if you want. You can try not to add any voltage, but I think it is for the better. The power consumption is only marginally higher, and this way you're guaranteed a better stability of the system. So the side effect of this several more, so it is a little bit more than 5, what is it, 15 watts. So the side effect is a higher temperature during operation, around 10 degrees higher, but keep in mind that is extremely budget CPU cooling solution. If you use something marginally better, marginally pricier, more expensive, around 15 to 20 bucks, you will get lower temperature. Now, as you can see, this is the old result, 886 points. So for overclocking the video card, we will be using MSI Afterburner again. You can see there are some settings here, but it is not strictly needed, as AMD drivers are quite capable too of overclocking also, though it might not be that intuitive, but let's do the things after we finish the rendering. So rendering is quite a heavy task, and you can use it for testing the stability of the processor. Also, you might want to do more thorough test. Here 1001 points, which is almost exactly the difference of the speed, 13% performance improvement, and we have it's even slightly better. That difference should not be taken into account, as the test itself has a slight variation between the runs. So basically, during rendering, you are getting that much performance as how much the clock speed of the processor was risen. You should not expect to get this much performance in any case, but 10% on average should be quite possible. So let's go back to overclocking the video card. The AMD Radeon settings in Global Wattman, they have quite a capable tool also. As you can see, you can see the different power states of the GPU, and you can change the power state in the last power state. That is what is used in turbo boosting the graphics processor. Also, you can change the speed of the fan. It has even integrated 0 RPM mode in the drivers. That is independent from the hardware implementation of the graphics card. Power limit and memory speed. You can change the memory speed, and this voltage here, that is not the memory voltage, but the voltage of the controller of the memory in the chip. And keep in mind that if you optimize the chip and, for example, you want to lower the power consumption and undervolt it, you basically cannot get under the voltage of the memory controller. You can change it directly here, for example, this, and you should always press enter after input or it will not get it. So if you lower it to 900, you can lower the states to 900 volts. So reset. But it is slightly more easier and convenient to use the afterburner. So what will we do? We have already tested the graphics card and we know its limits. The memory can go up to 200 megahertz. That is quite a nice overclock. For 10%, and the GPU clock can go to 1350 without upping the voltage. And if you add the maximum bonus voltage of 100 millivolts, which will result in, as you can see here, the base voltage in the high state is a volt 0.018. That will be a volt 0.118 volts, or approximately a volt and 120 millivolts. You can go up to 1400 on the core. So the interesting part is that in the Radeon RX 570 graphics card that we use for comparison in our review of GeForce GTX 1650 was again Sapphire Nitro model, overclocked to 1340 MHz, and it was running at 1.15 volts. So at 1350 MHz you are getting something that is slightly better and more economical. The thing, however, is that there is this thing called silicon lottery, or the capability of the chip, and for the Polaris chips there is this thing called ASIC quality. And as you can see, the current version has a rating of 77.9%, or this card ASIC quality is higher than 70% of similar GPUs. That means that we have got quite decent chip, so it overclocks well, and the maximum performance you can get from it is at 1400. That is even higher than the overclocked Sapphire Nitro RX 570. To be sure that you won't be power constrained, you should also increase the power limit. And this is our settings. So keep in mind that you should test it thoroughly, and unfortunately for now it is there is no single tool that will guarantee you absolute security of the overclock, even unless you test in several games. So we are applying the overclock. I used to use the 3D Mark stress tests that are good and consistent load, and they can give you a relative idea about how the card is behaving. Unfortunately, it seems that nowadays the 3D Mark tests are not big enough challenge for the graphics card. For example, TimeSpy stress test, I think it runs around 20 minutes, and if your card is not stable, most of the times it will fail in the beginning, and if it runs, it gives you results I think above 98%, you can expect a relative stability. So there are some different stress tests, different version for the different 3D Mark tests, but currently the game that loads the graphics adapter, at least in this current case with the Radeon RX 470, seems to be, from the games I've tested here, is the Battlefield 5. For example, the card was running at 1420 on the stress test 3D Mark, but only at 1400 MHz it was stable for extended time in Battlefield 5. Basically, you need to stress the card continuously with different games to check how stable it is. Now, let's see the effect of our overclock. Average check. 63 average, 52 minimum. You can see the CPU and the graphics card are running at our overclock speeds, and here is the upped voltage. You can see the settings are the same, and run. Again, we have the overclock processor and the overclock of the graphics card. But as you can see, substantially power consumption that not mistaken because that is the power consumption of the GPU, not the graphics card. So expect it to be run slightly So there you have it, 69 to 58. That is approximately 10% better performance, which should mostly be attributed to the graphics card. Of course, the difference will vary between different games. Some games may give larger performance boost because of the sometimes synergetic effect of the memory and the GPU overclock. For example, also the CPU will add its performance in the CPU bound situations. So from what I'm seeing here, the best results we get in Assassin's Creed Odyssey, that gets over 20% better performance after the overclock. Most of the times the effect in games is 10 to 15%, and in some of the games it is just about the difference between going to 60 frames per second average and below 60 frames per second average. So that's it, and you can expect some more tests and comparison between the overclock and non-overclock performance after this. Goodbye. Please like and subscribe to our channel. Have a nice day.